There's lots of uses for it. This is a typical refinery right here. This is what one looks like, and the closest one to where we live here in Woodland Park, there is, I believe there's two of them. I know at least two. I think they're both still operating in Denver. So there's two of them in the Denver area. Okay, let's talk about how oil is refined and look at it from an experimental perspective. It uses a process called distillation. So let's take a gander at this video clip.
Crude oil is a thick, dark brown liquid found deep in the Earth's crust. It's a mixture of different hydrocarbons, molecules made of hydrogen and carbon. Some molecules in the mixture are very small, just a few atoms joined together. Others are far more complex, with many atoms forming long-chain molecules. But as a mixture, it's useless. The different hydrocarbons need separating. The technique used is distillation. This simple apparatus is set up in a fume cupboard. Mineral wool stops the mixture spitting when it's heated. Crude oil is dropped into the bottom of the tube. A collecting bottle is put in place, and a thermometer level with the sidearm monitors temperature. The final step is to gently heat the mixture by immersing the tube in a hot water bath. The hydrocarbons with lower boiling points begin to vaporize immediately. They're flammable, so it's safer not to heat with a naked flame. As the vapor rises, it enters the sidearm, where it cools and condenses. This happens at about 40 Celsius. The hydrocarbons which boil at this temperature drip down the sidearm and form our first fraction. It's a colourless liquid. The temperature stays at around 40 until all the hydrocarbons with this boiling point have vaporized. The hydrocarbons left behind aren't hot enough to vaporize. Their boiling points must be higher. Once the first fraction has been collected, it's safe to start heating with a Bunsen. As the temperature rises, other hydrocarbons begin to boil. A new fraction is collected at about 60 Celsius. It's slightly yellow in colour. And so the process continues. By carefully heating the oil and collecting the liquids which condense at a number of different temperatures, the many different hydrocarbons in crude oil can be separated. This is known as fractional distillation. On a larger scale, a fractionating column is used. The oil is heated with an electric heater for safety. The vapour is condensed by a Liebig condenser and is collected in a conical flask. Hot vapour rises up the fractionating column. It's a long way to go, and the further from the heat source, the cooler it gets. Most of the vapour condenses on the glass spiral inside the column and drips back into the mixture. Only the hydrocarbons, which are still vapours at the very top of the column, enter the sidearm and condense to liquid. Industry uses the same process, but on a mammoth scale, in huge fractional distillation columns. The hot oil enters near the bottom, at a temperature of 330 degrees Celsius. The column becomes cooler towards the top. Fractions which remain as vapour at 85 degrees Celsius go straight to the top and are piped away. Different hydrocarbons condense at different temperatures, running off at various levels. Those with lower boiling points are collected at the top. Those with higher boiling points run off nearer the bottom. The longer the molecules, the higher the boiling point. Industrial distillation separates crude oil into useful fractions, each containing molecules of a similar size.
Okay, so hopefully that kind of helps illustrate how oil is broken apart. Now let's talk about oil production itself. All right, in 1859, Colonel Titus Drake, he reached oil at 70 feet somewhere in Pennsylvania. So before 1859, there really wasn't any use for oil. It was actually just that people would have these tar flats and stuff, and they would hate it. And it's like, oh, my land is ruined. And of course, now if someone finds that, and they think, oh, I'm a millionaire. Okay, 1901, the Texas Spindletop oil field was discovered and became pretty widespread use for fuel. They realized they could burn this stuff and it could heat their houses. But in 1920s, by the time that the automobile has been discovered, they realized that it could be used for automobile. Somebody invented, I think it was Henry Ford, invented the internal combustion engine that used gasoline. Okay, but then in World War II, they realized oil was probably the best fuel of all, and it overtook coal as the main source of energy. So all of a sudden now, oil became a huge important thing. So here is the production of oil. So from looks like 1900 to roughly 2010. Well, actually, probably 20 something here. Okay, 1900, hardly any oil, and you can see how the amounts of billion barrels a day have been used. This is from 2003. So in 2003, we're right here, and they're using more and more and more oil. This follows what is typically called, you know, the curve looks like this. Okay. Now, there's a very kind of controversial topic I want to talk about here today for just a few minutes. It's called peak oil. You see, oil is a non-renewable resource. That means there's only so much oil in the world. And the big debate that's going on, or one of the big debates in the world right now in this whole concept, is what they call peak oil. What they're saying is that at one point in the future, we're going to reach a point where we're going to reach the highest amount of oil that we could ever produce. What they're saying is it's going to follow a graph that looks like this. It's going to go up and up and up and up and up and up, and then we reach the point where we are now. And then the question is when will it start to diminish? Will it always go up like this red line thinks? Will we continue to, because that's what we need, or what we seem to think we need, or will it reach a point where it's going to come down? Because if it goes down, we've got problems as a society, because all of a sudden there's less oil, and if there's a certain demand and then there's less oil, then typically what happens economically is the prices will diminish. And when the prices diminish, the prices will go up, and then if the prices go up, that will cause lots of economic issues globally around the world. So this is a concept called resource depletion. Resource depletion. So if you have a finite resource, you only have so much oil in the world, and it's not being made at an appreciable rate. It's not like it's being produced underground very rapidly. It takes millions of years for it to happen. Then it follows what they call a bell-shaped curve. The question that everyone wants to know is, when is this point going to happen, when we're at the top? Some argue that it's already happened. Some argue that it's going to happen between now and, say, 2050. It's kind of a